Okay, welcome to unit number 3. This unit will focus on quadratic equations, and then towards the end we'll look at transformations. So quadratic equations, if you recall, these are equations that have an x squared in it as the most dominant term. So you won't see anything with a power greater than x squared. In this particular video we're going to look at two different forms of expressing a quadratic equation: intercept form and vertex form. All right. Day 2 we'll look at standard form. So intercept form, this is the first form we're going to look at. All right. In other words, we're just talking about different ways of expressing a quadratic equation. All right, so something that's going to end up having an x squared in it. All right, so intercept form looks like this. Okay, we have y equals a times the factor x minus p times the factor x minus q. So this form is also known as factored form. And we're probably going to refer to it as factored form more frequently than we will refer to it as intercept form. Alright, and it's pretty obvious. It's because it's all factored out. Okay. Now it's called intercept form because you can easily solve for the x-intercepts. If it's in factored form, you would just set each factor equal to 0 and solve. It would be very quick and easy to get your x-intercepts. Recall that x-intercepts are also known as the roots, or sometimes we refer to them as the zeros. Okay, the zeros. The graph of a quadratic, you should know what this is. This is called a parabola. Alright, so anytime you hear the word parabola, that is referring to the graph of a quadratic. Now parabolas are symmetrical about a vertical line that we call the axis of symmetry. And we'll abbreviate AOS for axis of symmetry. Now this symmetry line will always be the average of the roots of the quadratic. So in other words, because our quadratic has symmetry, if you were to focus in on where the roots are, I'll do a quick sketch up here. Alright, if we have a quadratic that looks like this, here's a root and here's a root. Okay. If you were to draw in your axis of symmetry line, the axis of symmetry line is a vertical line that's going to go right down the middle. Alright, if you were to fold the parabola over that axis of symmetry line, it would fold onto itself. Okay. Well, as it turns out, the axis of symmetry line is the average of the roots, okay, in terms of that x value. Okay. So the axis of symmetry will always pass through the vertex. Alright, and this is also known as the turning point. So on my graph here, this is my vertex. Okay, or my turning point. Now the vertex will be a minimum point on the function when the a value, remember a is this number in front, okay? If that is greater than 0, that will mean it's going to open upward, and your turning point or your vertex would be a min. And likewise, the vertex will be a maximum point if the a value is less than 0, meaning it's negative, and it would therefore open downward. So this would give you a maximum point. So we're going to use all of this information to produce a sketch of the graph of this function below. So of course we're not going to use a calculator. So notice it is in factored form, which we call intercept form. The advantage of this form is that right away we can identify the roots. Okay, so to help us graph this, we're going to find the intercepts. Let's start with our x-intercepts, which we refer to as the roots. Alright, so recall from last unit, to find an x-intercept, we're going to make y 0, So since it's already in factored form, it's very easy to get our answers of -1 and +3. So let's set up our scale here. Again, this is just going to be a sketch, which means we'll try to make it as accurate as possible. So -1, 3. Here's -1. Here is 3. We know that the parabola will be passing through those 2 points. Let's find a y-intercept. Recall, this is where we make x equal to 0. So we're going to have y equals 2 times. So now I'm putting a 0 in where I see an x. Okay, and so you just clean it up. Okay, be careful. All right, that's going to give you -6. So our function, our parabola, is going to be crossing down there at -6. All right, we mentioned up above that the axis of symmetry is going to be the average of the roots. Well, since my roots up here were -1 and 3, if I were to average these, okay, your axis of symmetry, it's very similar to a vertical asymptote line in that it is vertical, and it's always going to be expressed as x equals some number. So if I were to find the average of those two roots up above, of course we're just going to add them together and divide by 2. If it's an average, you're going to get 1. So at x equals 1, we're going to draw a dotted line, okay, which is not part of my graph, but I know that is the axis of symmetry. That's the folding line, so to speak, that's going to go right through the middle. We also know it's going to go right through the vertex, or the turning point. So, and we said earlier that, if we look back up here, the vertex and the axis of symmetry pass through one another. So the axis of symmetry is going right through that vertex. So we can use that to help us find the coordinates of our vertex. So my vertex, I know, is going to have an x value of 1. Okay, again, I'm taking this answer from my axis of symmetry, and that is the x coordinate of my vertex. And now I'm going to plug that into my main function to find out the y value that goes with it. So we have y equals 2 times 1 plus 1 times 1 minus 3. So y is equal to 2 times 2 times -2. So that is -8. So my turning point, my vertex, occurs at 1, -8. So if I were to sketch this, I know the y-intercept here was at 6, so 7, 8. This is where my function would turn. Okay, so we want to try to draw this symmetrical. It's going to have to pass through those intercepts. Okay, it's going to have to open upward because notice up here this 2 is a positive number. Okay, that's the so-called A. Alright, so A is greater than 0, so we know it's going to open upward, and our points would suggest it's going to have to open upward anyway, the ones we've already graphed. Okay, so there is our function. So notice we found x-intercepts, a y-intercept, the axis of symmetry, and the vertex. Okay, so that's our graph. Next form. Our next form here is called vertex form. This is another form of a quadratic. With our factored form, if we were to multiply those factors together, we would get something that has an x squared in it. Vertex form, alright, again, it's another form of a quadratic. It's going to have an x squared in it, and it looks slightly different. Okay, it is not in factored form anymore. It's called vertex form because you can easily read its vertex. Whereas with the previous problem in factored form, we had to do some work to actually get the vertex. So in the above form, the vertex would be h comma k. This suggests that you're going to change the sign of what you see on the inside there next to the X, and what you see on the end, we're going to keep that sign the same. Now, since the vertex goes right through an axis of symmetry, so here's my vertex, here's my axis of symmetry. Remember that the x value on the vertex is going to be the same as the x value on the axis of symmetry. So my axis of symmetry equation would be at x equals h. h because that's the x value of my vertex. So let's do the same thing we did with the previous example. We're going to graph this. So let's identify some key parts. We notice that this is in vertex form. So right away we are going to identify the vertex. It's kind of a reverse order from what we did with the previous problem. Okay? So the vertex, if we were to look at our function, look at this inside piece, we see a -2. That suggests that the x-coordinate is going to be +2. And on the end here we see a -1. So that is going to be the y-coordinate of my turning point, or my vertex. So let's start our sketch here. So 2, -1 is my turning point. Notice that in front we have a -2. So the a value is less than 0. It's negative. So that suggests that the parabola is going to open downward. Okay, so we're expecting that to happen. So my vertex is at that point. From that, we know that the axis of symmetry, remember it's a vertical line, so it's going to be x equals some number. Well, that number is going to be 2 because it's always part of the vertex. We said that since the vertex crosses through, or the axis of symmetry crosses through the vertex, those x values are always going to match up. So our axis of symmetry equation is x equals 2. So we're going to use a dotted line just like before to represent our axis of symmetry line. Okay? So it would be helpful if we can find some intercepts. So let's start with our x-intercepts. So of course we make y 0. So we have 0 equals -2 times x minus 2 quantity squared minus 1. So we have to solve for x now. So I'm going to add over this -1. So then we have 1 equals -2 times x minus 2 quantity squared. Then I'm going to divide over that -2 in front. So I have -1/2 is equal to x minus 2 quantity squared. To get x alone, well, let's first get rid of this square by square rooting each side. Uh-oh, I see a problem. I can't square root a negative number. We know that we didn't do anything wrong. Instead, if you read between the lines, this is telling us you don't have any x-intercepts, which, if we think about what we said earlier, we know it's going to open downward from this turning point, so it's not going to actually hit the x-axis. Y-intercept, let's grab that real quick. So we're going to throw 0 in for x. So 0 minus 2 quantity squared minus 1. Carefully clean this up. You're going to have -2 times a -2 squared minus 1. So this is -2 times 4. Let's scroll down here. -2 times 4 minus 1, which is -9. So 0, -9 is a point that this is going to pass through. So let's say that's down here somewhere. Okay, and if it's a sketch like this, it would make sense to label it. Okay, if your scale kind of runs out of space like mine did. And from there, we have enough information to draw our parabola. Okay, try to make it look symmetrical. Alright, again, this was our axis of symmetry line. Okay, so it's always a good idea to just label your key points. So this was 2, -1, that was my vertex. Okay, Pretend I did that in the last example. If you want to just go back and make sure that you have labeled the coordinates of your key points like you see me doing there and there. And it doesn't hurt to write that this is my axis of symmetry at x equals 2. So we want to label all of the key features as a general habit. Okay? Thanks a lot. Bye-bye.